All right. Let's solve the 3D Leetcode problem. So 3D Leetcode problem is a count partition with the max mean of difference at the most k. So we are given an integer array and an integer k. So our task is to partition nums into the one or more like non-empty continuous segment, such that each segment, the difference between the maximum and minimum elements is at most k. So, alright. That may be a little bit difficult to understand at first when we go through to read the problem. So we have to return the number of waves of the partition nums under this condition. Since the answer may be too large, we have to return the modulo of the 10 power 9 plus 7. So let's try to understand the problem first before we start writing any single line of code. So we are given 5 numbers of array, and then our arbitrary k that we could have is maximum of 4. That means whatever the minimum or maximum in our segment, it's a separate whatever, it should not be more than 4. So let's try to run through it. If I have to write down the numbers in here, so we have something like 9, 4, 1, 3, 7. So according to this, what we can do is we can create the many possible segment in here. The first approach is quite straightforward. I just create like each array, each individual items as a one continuous segment. That means like the maximum and minimum values will be the same. The maximum is also 9, minimum is also 9. So if we subtract the maximum and minimum, that will be the 0. So which is stay less than the 4, that is under our condition. So if we really want to focus, we can forget about this part. This is just a given from our existing parameter. Different. So the most important by the difference between its maximum and minimum element is at most k. So that is really where the catch came in. So then we got like one approach in here. That is a 1 in here. So let's go for the next approach, next asymmetry given by the asymmetry 1. So we can split like we can keep this segment by previous way. Then we keep the 3 and 7. So the maximum is 7 and the minimum is 3. So 7 detect the 3 is a 4, which is quite matched with the value in here, 4, and the stay not greater than the arbitrary value k. So that's why this one is also valid. So we can think like, how about other approach, something like, okay, I can create the one interesting arrays in here. Let's consider like we keep these two, 9 and 4. Then how about we take these 3 continuous items as a subarray? So that way create the maximum value is a 7 and minimum is a 1. So 7 detect 1 will be 6, which is totally invalid because our value should be the at most of 4, which is 6 in here. So we're gonna choose that. So if we move to the next step, let's just try to go through with the given arbitrary asymmetry by asymmetry 1, 9, 4, and 1 and 3, and 7. So since we can totally ignore these, and then how about 1 and 3? So 3 detect 1 is true, which is totally under the 4. So that one, that's why the given values here is valid. How about the next step? We can choose this like 9 and 4, 1, and then 3 and 7. That is also valid. 4 minus 1 is 3. How about we take the 3 and 7 together? 7 minus 3 is 4. That is also valid. How about we take the like something like 4, 1, 3, something like this, and 7. So 4 minus 1 is 3. So that is why we are receiving like total of 6, and we return the total count of this in here. That is why how we get the outputs of 6. So let's move to the second asymmetry. We given like 3, 3, and 4. it's pretty straightforward. We can only get like, okay, there's where the really interesting things come in. Since the arbitrary value case is 0, okay, this is the first approach according to the previous example. So we are not allowed to choose any number, because if we choose like 3, 4, and 3 as a partition, that will be the false, because if we detect 4 minus 3, that will be the 1, which is greater than 0. Yep, and that's why we receive like 3, 3, and 4. So if 3, 3, 3 minus 3 is 0, 4 is 4 minus 4 is 0. So that's why the output in here is 2. So also the given the example, our answer may be too large, so we need to retain the modulo only. And then according to their constraint, the number of lunch could be minimum of 2 up to the 5 into 10 power 4. That's like 50,000 maximum. And then the number range, each number could be 1 up to 10 power 9. The k could be go from 0 to 10 power 9. Alright, we pretty much understand about the question, and we can start writing the code a little bit. So my first thinking was, how are we going to solve that without using any nested data structure? The only thing that comes in my mind is, if the problem comes with like ask you to do the subsequent of the array and then difference between these, that's pretty sure is a dynamic programming program. Let's check. It's really the dynamic programming. Oh, exactly. We don't even need to ask the fortune teller. That is exactly the dynamic programming with a Q. So what I'm going to do is like, let's calculate the count first. Let's call like nums.count as we usually do. And then let's check our number of n could goes to the 0 or not. Alright, that's gonna go 0. That's okay. And then what are we going to do is, I'm gonna create something called dynamic programming array, which is going to partition the item. What I really want to do in here is a dp of index will be representing like 0 dot dot like this. So we just want to create the something like mock array first. It should be repeating. What is wrong with me? Repeating. Alright, repeating 0 and count 0. It should be the count plus 1. So the reason why I'm having a count plus 1 is we want to keep an extra 1 space to keep track of what is the total number of the dp. And then that will be the last will be we put in the answer in here. So let's consider that we have a count of 1, 2, 3, 4, 5 in here. Now, alright, I just create the array like 1, 2, 3, 4, 5, 6. So that is what I'm creating here. Just a simple, nothing magical, just pretty, and just a native from the Swift. So next step will be I'm going to use a preference. Let's consider like that is also the exactly similar to the previous one. And then count will be the count plus 1. So initially I'm gonna put the 1 as an initial reset. The same for the preference. Also 1. So alright, I'm gonna use a 2 pointer in here. Let's call like left is a 0, and then I will call the right pointer that will be going from 0 to count, which is here. And then I will call the values like nums of right. Since we are going from 0 to the index of 1, 2, 3, 4, so that is not going to cause us the index out of bound. So what I want to do here is I want to keep track of the minimum Q and maximum Q. So technically in here, if I am in the other different language like Python, I can simply use the deck, which is the DQ. We can easily like append and prepend from back and front. But in here, I don't want to add any other extra data structure in here. So my approach is just call like a to array, something like minimum q. That's what I can think of it for now. Next is a maximum q, which is also the integer array. So instead of using the something like dq in here, I'm just creating a to array. That is okay. And then what I'm going to do in here is I'm gonna need one more extra variable that is going to keep track of our head for minimum and maximum. Let's call like 0 initially, and then maximum head will be the 0 initially also. So what I will check in here is if the number is keep increasing, I will put into the minimum queue. How are we going to do? Like while I will check like minimum queue dot count is greater than the minimum of head. So initially our array is 0. That would be resulting in a 0, and our minimum head also 0. That would be false initially. And for names of minimum q dot less item, I can use a false wrapping in here. Bear with me for a while. And then if this number is greater than or equal to our value, which is our index in here, what I am going to do is, if the number is greater than, I'm going to remove the number from the minimum q. The same for the maximum q. I can just copy it. Let's call this is increasing. This is a decreasing in here. So I will check the same approach here. Maximum q dot count is greater than the maximum of head. I will just take it off the maximum q index dot less is less than or equal to the value. Since this is a maximum q, we need to check like we have found the number that is greater than our. Okay, one thing you need to think is this is a sorted. So if it is a sorted one, so we can think of it like we can easily find the less number of the maximum is the largest. So that is the smallest in here. What I'm going to do is I'm going to remove the less item of the maximum q also. So before that, if we're gonna find anything, I still need to append like less item, something like minimum q dot append. I'm going to append the index for the minimum q, the same for the maximum q. Yeah, so I hope that won't make you guys complicated. Wait, I totally forgot the one things in here. So as usual, I need to create like something like let mod. That will be the 10 power 9 like 7. Let's create like 1, 3. Alright, that is what we need to do. So currently, okay, just return the dp of the count, which is a less item. I just want to show how is it look like after the minimum and maximum q is happening. How about we bring like here, minimum q will be the, and then that will be the maximum q. I just want to point out like what I'm doing here to you guys. Alright, what do I do wrong in here? Alright, I have one extra dot in here. Try to run again. Alright, so that is what I'm exactly doing. Since the number is not in the item yet, I just append to the minimum q, which is a 0. The same for the maximum q. Next is we have a numbers in here. I will do the same manipulation here. So at the end, I got like 2, 3, 4. So index of 2, 3, 4 is in here. And next is 0 and 4 is in the maximum q. So the 2 maxima I can find is 9 and 4. The 3 minima I can find so 1, 3. 3 and 4. So that is totally, I'm doing a separation of between the maximum number and minimum numbers by taking the index. All right, let's move forward. All right, I need to shrink it now. That is where the real game comes in. Let's call like our nums of maximum q of the mass head. So mass head mean like we are checking the index of the maximum head here. What will happen here is if the maximum head is currently originally a 0, that means the max q, let's consider this is 0, mass head is 0, so the number is totally 0. What I'm going to do is I'm going to detect the nums of minimum q of minimum head. If both of them are greater than the k, that literally means we can find the valid numbers. So we need to move our index from the 2-pointer from left to the right by 1 index. Right, left plus equal 1. After that, after we move the index, we can remove based on the... Okay, if we have to explain, like we have 2 items in here. So originally, our right index, okay, this is a left index. Let's go, okay, let me write that as a left. I don't know why this is so ugly. All right, and this is a right. I will change the arrow to the right. So according to here, since we can find the valid number, mean like our difference of the maximum and minimum is greater than k, what do? We move the left index to here. Since we also start at the same index, the right index will move. That is what I'm doing here. So after we remove the left index by 1, we will remove if a minimum q of minimum head is greater than the left. We just need to check like, what if the whole value of the minimum head is less than the left? So we can increment the minimum head by 1. So technically speaking, we are just checking like, let's call like minimum head is we are just comparing the numbers of the minimum q. So let's consider like we have a minimum q like 0, 1, and then from the minimum head, which is a 0, we are check like our minimum head, since it is a sorting, so we can consider like if less than the left mean our index in here. So we're gonna update the minimum head or index to the from 0 to 1. That is what we are doing here. The same if maximum q of the maximum head is less than the left, what I'm going to do is I'm gonna update the maximum head index into the plus equal to 1. So after we updating the index in here, that is where all the sub-array number calculation came in. Even though the logic seems like a little bit huge, bear with me, that is really worth to understand the whole problem set. So I'm gonna check like, let's call it like an index would be the right plus 1. So that is technically the prefix length. We are now trying to calculate the every item or left and right of the sub-array. Let's call like what is the minimum number in here, and then we're gonna detect the minimum number from the maximum number. That is what we are doing in here. And then let's call like it's a prefix length. So after we cut the prefix length, we'll check like if left is equal to the 0. That means we are at the beginning in here. The answer is straightforward. We just return our index. Let's go index, and then that will be the our preference, which is a preference array in here that we created. Preference of right index mod by the mod. If left is not 0, that means we are in the middle of something in here, like this. We will do like, let's check like a value. I am using the values in here because we have already one value variables in here. I don't want to make you guys confused. So what I'm going to do is like if value will be our preference of right minus preference of left minus 1. So they technically speaking, like we are detecting the sorted numbers in here, and then that we are going to update it inside that. So if we check if value is less than the 0, we just increment the value by the mod. And now we update the dp in here. So the dp of index will be our new value. Wait, it should be in here. Yeah, that is just to update the value with the mob. And then we're gonna update the dp in here. So next step, what I'm going to do is, that is where everyone is waiting for the answer. So we have an index of the preference. So originally we are started as a right plus 1. So since we have an original value of 0 is a 1, so we just put to the second item, right plus 1, and then that will be the preference of index minus 1 and our dp of index. That is what we actually want. If that is where the real updation of the preference comes in. So if we have a preference of index is greater than or equal to the mod, what we're going to do is we're going to update the preference of the index will be the minus equal to the mod. That is, we play with the mod, and then if everything went well, our count will be the answer. Let's try to submit. Since we don't use any other spare data structure and animal data space in here, so the time and space complexity both will be the O of n, if I'm not wrong. Yep, that solved the problem. And even though I did make the daily Leetcode problem in time, I wish you guys understand the problem and able to crack it during the interview. That's all for it, and I'll see you in the next one.